will use to create this model. However, many Boolean operation can be used in Ansys. Okay, now we have to create a rectangular diagram first. Okay, how to do that? Okay, preprocessor, modeling, create areas, rectangle, okay, and by two corners. And then we are given this pop-up menu. Okay, how to do that? Okay, from the tutorial thing, we are given as 0, 0, 200, and 100. Okay, now we have a rectangular blue box inside our GUI. Okay. And then we have to create the circle. How to create the circle then? All right, how to create circle? We have to use preprocessor also. Okay, preprocessor, and then modeling, create, and then now we choose a circle. Okay, and we have to pick the solid circle. A pop-up menu will appear, and WPX is 100, 50, and 20. And then press OK. Okay, now you see the small circle in the middle of the red of the big the blue rectangle. Okay, this circle will deduct later on. Okay, we want to have a hole inside this rectangle box. Okay. Subtraction. Okay, now I want to subtract circle from the rectangle. Prior to this operation, your image should look like this one. Okay, and to perform this Boolean operation from the preprocessor menu, select the preprocessor and operate. Okay, operate, and then we pick Booleans, subtract. Okay, and subtract what? Areas. Okay, a pop-up menu will appear. Okay, we have to choose which one the main first. Okay, the main thing, the big thing that we want to deduct. Okay, all right, we are picking the the rectangle. Okay, a notification appear. There are two areas of this location. The pick area 1. Okay, press OK. Okay, and then we pick OK. All right, now they minta we choose the things that want to deduct. Okay, pick next. Okay, pick the red circle, the circle in the middle of the rectangle. Okay, okay, and then press OK. All right, now we have a rectangle with a hole. All right. Ensure that the rectangle is selected, otherwise click next. Okay. All right, so we have this one. Okay, we are done with the geometry part. Okay, now we have to define the element. Okay, but still in the processor menu, element type, and non-defined. We don't have any element yet, so we add element that we want to analyze. Okay, this thing is a structural problem, so we take solid. Okay, so we have option of this one of this quad 4 node and then 8 node, brick, tetrahedron 4 nodes. Okay, what one is this one? This is the only option that we have. Okay, and then press OK. So now we have different element type. We have type 1, plane 182. Okay, and then we pick options. Okay, option according to the we call that to the tutorial. What I want to choose is that in under K3, plane stress with thickness. Okay, K3, we choose plane stress with thickness. Okay. And then we can close. Okay, we have to define geometric properties. Okay, in the preprocessor menu, and then real constants. We don't have a real constant yet. Non-defined. We can add. Okay, now we have type 1 plane 182 is real constant. Okay, and then the thickness that we want to have in this problem is 20 millimeter. Okay, be okay, and then close. Okay, and then material properties. Material properties. And then for this one, we pick a preprocessor material prop, material models. Okay, material model. Okay, material model number 1, we choose structural, linear, elastic, isotropic. Okay, and Ex is the modulus of elasticity of the material. Okay, and material we want to study is a steel or mild steel, and the Ex is 200,000. 200,000. And PRXY is the Poisson ratio of the material, and Poisson ratio is 0.3. Okay, be okay, and then we can cross this one. All right. Mesh size. Okay. Next is mesh size. And what is apa final element without meshing ya? Kalau nampak the thing in meshing, and you will know what the meshing is. Okay, preprocessor, meshing. Okay, size control, manual size, areas, all areas. Okay, and this for this one it depends. Okay, 25 is the jarak of the mesh length. So kita letak whatever number that we want. Okay, between 1 to whatever number. Kalau you letak 100, your apa atau 200, your mesh akan ada satu unit sajalah. Then kalau kecil akan jadi kecil lah your mesh. Okay, kita letak 20 katakan. Alright. Okay. Now we can mesh the area. Okay. Mesh. Meshing. Now we mesh preprocessor, meshing, mesh areas. Okay. Free. This is a map. You want to have a free. Okay. This is where we choose the area they want to mesh. Okay. Pick the area and then pick OK. Okay. Since our size that we have just now is what you call that? 20. So now we have macam ni lah. Okay, meshing of the structure. And notice that all elements they have 4 corners. 1, 2, 3, 4. Walaupun bentuknya lain sekalipun masih ada 4 corner. Okay, this is okay, cuma ada satu je yang triangle. Okay. That's why dalam the mesh area 3 contains plane 182 triangle, which is not applicable, not recommended in this type of library lah. So dia suruh dijadikan, okay. Sedangkan kita gunakan quadratic 6 or 8 node element if possible. So what we can do, we can change the mesh size. Okay, we can change the mesh size by do the mana mesh size. Okay, size control. Yeah, meshing, size controls, which is manual size, global areas, all areas, and then we can change back the punya. Okay, sama ada 10 atau 15. Kalau kita buat 10, it's very fine punya meshing. Mesh. And then okay. Okay. Now our structure is remesh. And dia punya meshing nampak cantik sikit ya. Tapi walau bagaimanapun masih ada lagi triangle mesh, which is not really recommended in this structure. Dia kan di stiff bending. Okay. Ada berapa triangle? 1, 2. 2 triangle. So you can redo lagi. Size controls. Manual size area. All areas. So I follow the tutorial. Mesh. Free. This one big. Okay. All right. Okay. Now all our element are quadratic element. Okay, all of the four corners. Okay, next step we dah ada meshing apa semua. Tengok tutorial, dalam tutorial ni lagi kasar ya, compare dengan our model. Okay, and then please make sure to save our work all the time ya. Save DB, bukan save you can save analysis ataupun whatever. Okay, make sure you save. Kalau tak penat dia. Okay, solution phase. Now we are in the solution phase. We are already done with the preprocessor. Now we are in the second step, which is a solution phase. Okay, define analysis type. Okay, analysis type. Solution, analysis type, new analysis. And then is it static, model, harmonic, transient, spectrum? This one is still under static case. All right. And then we can apply constraint for the constraint that you want to apply. Okay, define solution, define loads, apply structural displacement on lines. We are choosing this the left side of the rectangle. We want to fix it where we don't want to make it move. Okay. And then audio F, we choose audio F and constraint value, which is 0. Okay. Okay, now this structure will not move anywhere, sama ada to the X direction atau Y direction atau Z direction. It will not move at all. These points ya, samalah atas dan yang walaupun tak nampak dia punya simbol kat sini, kat atas dan kat bawah, but it all the same. Alright. Now we want to apply the loads. Okay, ada constraint, ada loads. Okay lah, inilah yang dipanggil boundary condition. Okay, boundary condition. Sini is free to move. This one is not free to move, meaning that dia punya displacement equal to 0. Okay, so what we do? Sama lah. Solution, define loads, structural displacement on lines, and then we pick the other end of the rectangle, press OK. Okay, now we use what? Okay. Oh, silap. This one, not this one. Bukan displacement, but force moment code. Okay, let me structural pressure. Okay. Solution, define loads, structural pressure. Okay. Pressure on lines. We pick on lines. We pick the lines here and press OK. Okay, now we have constant value pressure and the value, and then this is the constant. So leave blank is uniform pressure. Kita tak perlu isi apa-apa ya. Alright. So over here we put -1. Okay. Apply. Okay. Actually kalau dalam gambar is just all the way, okay? But it is uniform pressure, dia bagi satu je lah, okay? Padahal kat semua surface ni memang ada pressure ni ya. And then why negative? Padahal kat sini is towards x direction, positive x direction. Okay, the answer is that negative pressure is towards the structure, okay? Towards the structure. Positive pressure is away from the structure, okay? Let me recap. Oh, silap ya. Dalam pressure, positive pressure is menekan structure. Okay, positive pressure menekan structure. Negative pressure is pulling the structure. Jadi that's why nampak this one is away. Tapi in our value we pick negative. Alright. Tekan okay. Alright. Memang different lah. Kalau this one sebab this Ansys is Ansys 2020 yang dalam tutorial ni tak silap Ansys berapa ya? Ansys version 5 kot. Okay, lama dah. Okay, now we want to solve the problem. Okay. Solution. Solve current as. Before that we save dulu ya. Okay, kalau dah puas hati dengan our geometry and our boundary condition, and then I hope you are satisfied with this problem, and then you can prepare to solve current as. Bismillahirrahmanirrahim. Okay. Solve. Tekan okay. Okay, solution is done. Good. Okay, we can close down. Okay, we can cross. Okay, now we can view the results. So we can do the hand calculation, senang aja for this thing. Kalau you can do your own calculation theoretically, okay. But you want to see, okay, post-proc, general post-proc. We read result. First set. Okay. Every time after you do your solution, kalau solution tu cantik, and then you have to general post-proc and then read result. First, yeah. First thing you do, you must read result. Otherwise, you takkan ada result at all. Alright. So I'm referring the. Alright. So now you can see in the plot result. Okay. You can see the deformed shape. Deformed and undeformed. Okay. Now you see. I snap this photo for you to see. Okay. Yang black area ni ialah yang asal, and the blue area ialah deformed shape. Alright. Apa lagi yang kita perlu tengok? Alright, deflection. Okay, plot result, plot result, general plot result, and then nodal solution, plot result, nodal solution, contour plot got, okay, contour plot, and then nodal solution. Okay, dalam nodal solution ni you can tengok the whatever result that you want to read. Okay, tapi student dia suka tengok von Mises, saya tak tahu kenapa. Mungkin sebab nama dia glamour kot, von Mises. Okay, this is the result of the von Mises. Let me capture this image and then share to your WhatsApp group. Alright, and then element solution, the nodal solution, ada element solution, ada element table. Okay, ada banyak lagi you can view ya. You can play around with the thing also. Okay, in the nodal solution here you can ada stresses and then ada apa benda lagi yang kita tengok. Deflection, dia tengok deflection. Stresses, nodal solution ni tengok deflection. Okay, alright. Saya tengok lagi deform shape. Dalam deform shape ni, okay, ada dah tadi. Vector plot, plot plus quantity, inflammable list, result, query option, and the element solution. Total mechanical strain. Nanti kalau you ada masa, you cari deflection, total deflection ataupun deformation. Element solution, stress, total mechanical stress, plastic strain, stresses, S component, whatever the thing, mechanical stress. Okay, for example, this one. Nodal solution, DF solution. Okay, di displacement kita tengok X displacement. Yep. Okay, this is example of the X displacement. Alright, so itulah first our tutorial thing that we want to see, and then alternatively you can also do the selain daripada what you call that, selain daripada graphic menu instruction, we have also the what you call that, file menu instruction. Kita panggil apa ya? Let me check kat dalam tutorial ni. Sebab tutorial ni ada yang alternative given. Okay, alternatively the command, okay, command line instruction. Okay, command line instruction ni you have to know the command word lah. Okay, boleh buat. Kalau tak, memang tak akan tahu. Okay, for your information, I don't presentation. So siapa-siapa yang tak tengok tu, and then you can refer to your friend. You can ask your friend who follow, because I don't record. And then for those of you who like to view further, you can view the YouTube channel ya. Bukan my channel lah, some other people in channel. Okay, any question you can ask in the WhatsApp group as a group thing. Okay, I'll give you 1 minute, 10-minute rest. Kita akan continue at 3:10, 3:05. 3:05 is actual tutorial of the plane stress bracket. All right. So I stop my